Welcome to the Explainer. So today, we're going to tackle a question that, sounds pretty simple on the surface, but trust me, the answer is going to push the laws of physics right to their absolute limit. And it all kicks off with something most of us do every single morning.
It seems plausible, right? You stir something, that creates friction, and friction creates heat. But as we're about to find out, the journey from just a gentle swirl to a full-on rolling boil, well, it's going to take us from our kitchen counter all the way to the brink of catastrophe.
All right, so first things first, let's start with the basics, right? What actually happens when you or I stir a cup of tea at just, normal everyday speeds?
Okay, so here's the deal. Every single time you move that spoon through the water, you're literally converting the energy of your motion, that's kinetic energy, into thermal energy, which is just a fancy way of saying heat. So technically, yeah, you are heating up your tea. But the real question, the one that matters, is by how much?
And this is where we hit our first major roadblock, is the fundamental problem we're up against. See, while you're adding this tiny, tiny bit of heat with your spoon, the tea is constantly losing a way bigger amount of heat to the cooler air all around it. It's a battle you just can't win.
And yeah, this really shows just how lopsided that fight is. Even if you went crazy and stirred your tea as hard as you could for a whole minute, the temperature increase would be so small, so ridiculously tiny, you couldn't even measure it with a normal thermometer. The bottom line, your tea is actually getting colder, not hotter.
So, what's the verdict? It's pretty clear. To win this fight against heat loss, we've got to add energy on a totally different scale. We need to go, ridiculously, inhumanly fast.
All right, so let's really crank up the speed. What if we could stir that tea so incredibly fast that the tip of the spoon actually breaks the sound barrier? Right there, inside the teacup.
Okay, and this is where the physics gets wonderfully strange. At these kinds of speeds, the simple rules of friction we were just talking about, they just don't apply anymore. The spoon is moving so fast that the water molecules can't physically get out of the way in time, and that's when a whole new, kind of bizarre phenomenon takes over. And that phenomenon has a name. It's called cavitation. Basically, as the spoon just rips through the tea, it leaves behind this little pocket of almost vacuum. Why? Because the water just can't rush in to fill the gap fast enough. The pressure in that spot drops so low, so fast, that the water right there instantly vaporizes, and poof, you get these tiny little bubbles.
I love this analogy. It just perfectly captures how impossible the situation is for the poor water molecules. The force of that spoon is just so immense that the liquid can't keep up. No way, no how. And that's what creates these little momentary voids.
But here's the kicker. The real energy release happens in that final step. See, as soon as those vacuum bubbles pop into existence, the huge pressure of all the water around them makes them collapse. They violently implode. And trust me, this process is incredibly powerful.
So with every single one of those collapsing bubbles, you get a tiny shock wave and a little burst of heat. You would definitely warm the tea up, for sure, and you'd almost certainly shatter the teacup from all the vibrations. But you still wouldn't get it to boil. We need even more power.
Okay, so if stirring at the speed of sound isn't going to cut it, well, there's only one place left for us to go. We have to push our spoon to speeds approaching the speed of light itself. And at these kinds of speeds, we're not just dealing with fast-moving water anymore. Oh no. We are now deep in the realm of Einstein's special relativity. This is where the basic rules of mass and energy, well, they start to get really, really weird.
So, let's just pick a speed, shall we? Let's say just a tiny fraction shy of the universal speed limit. The amount of pure kinetic energy we are about to dump into this one little teacup is, it's astronomical. And the consequences? They're going to be immediate.
The very instant that spoon makes contact with the water, the energy transfer is so enormous that it doesn't just boil the tea. No, it completely bypasses boiling. It rips the water atoms themselves to pieces, stripping the electrons away from their nuclei. Your tea is now a superheated ball of plasma. And the cup? The little ceramic cup? It doesn't stand a chance. Of course not. It's vaporized in an instant. There's just no way it could contain the kind of sun-like temperatures and insane pressures that have just been unleashed inside it. Now, all of that incredible energy has to go somewhere. And with the cup completely gone, it expands outward in a blinding flash and a catastrophic shockwave.
We're talking about an explosion with the force of a powerful nuclear bomb.
So congratulations, you did it. You have successfully, and I'm using air quotes here, boiled your tea. The bad news? You've also vaporized your kitchen, your entire house, and probably a pretty significant chunk of the city around you in the process.
And it just goes to show, doesn't it? Sometimes the simplest questions can lead to the most extraordinary, and in this case, literally explosive answers. It really makes you wonder, what other cosmic secrets are just hiding in plain sight in the most normal parts of our everyday lives?